Hello everyone and welcome to the final Physics 210 lab simulation walkthrough. As always, my name is Alec and let's get started. So today we're going to be talking about calorimetry, and unfortunately Colorado's PHET simulations didn't have one for us this day. So we're going to be using this simulation right here. So go ahead and navigate to that experiment and open it up, get to about this point in it, and we can get started. Before you really start any of that, as I've probably said at the beginning of all of these videos, go ahead and read through the attached lab manuals theory section, and note that we'll be making a couple slight adjustments to the procedure here. So the attached lab manual has you essentially starting. We're going to be taking like a metal in a cup and putting it into the calorimeter, and we're going to heat the metal up before putting it in there, whereas the attached lab manual essentially has you do the opposite. It cools down the metal and then puts the metal into a hot cup. So, I mean, the physics is all the same. It's just going to be a bit different because for some reason the simulation doesn't allow you to do things the other way. Got some relevant equations for you, so go ahead and take a look at those and use those when you need them. Anyway, let's jump in. So we are told to click the solid section on the left here, and the first solid that we'll be dealing with is copper. And then we're told to set the mass of the metal to 50 grams, so you can drag this or just should be able to type it in, but maybe I can't for some reason. But yeah, set it to 50 grams. And now to set the temperature of the heating element on the left to 100 degrees Celsius, which I will do now. Alright, and now we have to click next on the simulation. So now we're controlling this guy, and we will fill the calorimeter with, let's see, 200 grams of water. Alright, and we're told to leave the water at 20 degrees Celsius, and we're going to actually click both of the show specific heat things here. That way you can read off the specific heats of what you're experimenting with. And we're told to, with a timer handy, press start and record the temperature from the calorimeter every 5 seconds for 20 seconds. So I'm just going to read it off. Of course, you can play along at home and time it yourself. But if you'd like to use the measurements that I'm reading off, go for it, noting that they'll probably be a little bit inaccurate because my reaction time isn't incredible. Alright, so now we're told to hit start, and then once the thing is placed in there, I'll start the timer. Alright, so after 5 seconds, we're at about 21.2. 10 seconds, we're about 21.6. After 15 seconds, after about 2.17. And after 20 seconds, about 2.18. So note that the experiment actually runs for a total of 20 seconds. So when you're taking the last measurement, you can just wait for the experiment to stop. And so hopefully you got all that data down. If you need to rewatch that, go for it. And next we are told to repeat those steps for iron and aluminum. So I'm going to hit reset on here. Unfortunately, you have to reset everything when you reset things. So let me just run through all that real quick. Make sure you're recording the specific heats as you go. You're going to need those to make some calculations later. Okay, 200 grams of water. Alright, now let's start. Alright, after first 5 seconds, about 21.4, about 21.8, about 22, and then the final temperature is about 29 or 22.09. Alright, so now we're told to set this experiment up for aluminum, so we'll do that. Give me a second to get that all set up here. Alright, aluminum, 50 grams, 100 degrees Celsius, water, water, 200 at 20, and go ahead and start. Alright, so after the first 5 seconds or so, about 22.5, about 23.5 for 10 seconds, about 23.9 for 15, and to round it out, about 24.10 for the final. Alright, so once you've gotten all that data, if you need to rewatch this video, of course, feel free to get all of it. You should be able to go ahead and answer all of these questions. Keep in mind that the original lab manual had you solving for the specific heat of the metal, but unfortunately, for some reason, this experiment, you can't let things, it doesn't go long enough to allow the heat to reach equilibrium between the metal and the water. So if you could do that, then you could pretty easily calculate the specific heat of the metal, because when they're equilibrium, they'd be the same temperature. But this experiment makes it such that the metal is still somewhat hot when it's in the water, because it doesn't allow it to run long enough to actually get to equilibrium. So you could theoretically calculate the specific heat of the metal if the experiment let it go to equilibrium, but since it can't, we're just having it show us the specific heat of that metal, and then once we've done that, you can actually calculate the time or the temperature difference given this equation here. So basically, instead of calculating the specific heat, we're calculating the change in temperature of the metal in this experiment, and that should be just fine as well. So go ahead and do your data analysis and your questions, and then write up your lab report and go ahead and submit it, and pat yourself on the back because you have just completed the lab section of Physics 210. All right, well, have a great summer, everyone.